Is it just p plus 5?
Yep, you
times
just
that?
write those two in parentheses up top and the p plus 1 in the bottom. So if I write this thing like a gigantic fraction,
Wait, like this?
like I'll show you right here, like this,
Oh.
the
Okay.
whole thing over p plus 1.
Okay, so p plus 3 over p plus 1. Okay, sweet.
And then, so let's
restrictions.
talk about restrictions because it's weird with these, because it's really like a quadruple decker fraction right there. So if we think about this, if I get -6 right here, it makes the bottom equal 0, can't divide by 0. So first restriction, p cannot be -6.
And that's because of this part?
Yep.
Okay.
So if you think about it like this, because I'll share this with you, load it to YouTube and share it with you. So if you put a -6 right here, it screws up the whole thing.
Yeah.
If we put a -1 right here, then this whole bottom becomes 0. And again, you can't divide this fraction by 0. Okay?
And then
So
also,
basically,
can you just set them all equal to 0 and then
except the very top one, except this one right here. That's the only one that doesn't matter.
Why?
Because if I get 0 here, so let's say I put a -5 right here, that just makes the bottom or the top 0, and it's okay for something to equal 0. Because 0 divided by anything is 0, right? But I can't divide by 0, so if I get a -6 right here, that messes it up because I
Okay.
can't divide by 0.
Okay.
If I get a -1 here, then it makes the whole bottom 0, and you can't divide by 0 because it's the whole big top divided by 0, can't do that. If I get a -6 here, no dice. If I get a -1 here, no dice.
Okay.
Okay, so this should be 3 though. P plus 6, P plus 3. Just realized. So your restrictions are P cannot be -6, -1, and -3. -6.
Oh, right. 'Cause
-1,
anything that's been in the
-3.
numerator.
Right.
But then if it's, yeah. Okay.
So for your little helpful hint in your multiple colors, I would write set everything except the numerator for restrictions. Try to make it as brief as you can so you don't go crazy.
Okay.
And if you want to
Oh, there
use,
we go.
because I've got the beautiful colors as well,
Okay,
you can
wait.
use those if you want
What do
to.
I say?
So I would say, set everything but the top numerator equal to 0. Like first numerator, maybe first numerator would make most sense. In every single one of these problems, you want to factor completely as a step number 1.
Yeah.
Even the graphing ones, like literally everything. So the way we get you from like that 79 test average to in the 80s is like once we're done tonight, if you have time tonight,
Yep.
are you going to jam with the,
No, today
Not
I
today?
have so much to do.
you just can't?
No, yeah.
Yeah, I hear you. It's a crazy time of year with school.
Yeah.
It just kills you, right? So wait, right? So you get some time to marinate on all this stuff.
Yep.
And then later tonight, any problem you find hard that we did, you can listen to the video, listen to the explanation, and then do the problem.
Yeah.
Because you can print out another one of these, right, from the
Yep.
website. So you get a clean look. You never do it like when you can see the work,
Yeah.
because you want that clean look just like you're going to get on the test. And then study all these,
Okay.
because that's what'll really, because any kid that struggles, like, do you have test anxiety too?
It kind of depends on the test.
Okay. And how prepared you are, most likely,
Yeah.
right? So, like, any kid that struggles in math, it's knowing the first step of a problem that kills them. Like, if I can give you the first step, you can at least get halfway through and get half the points on the
Yeah.
problem. And then it's just how many stupid mistakes you make, basically,
Yeah.
right? So this helps you know the first steps or like a key step within the problem. So study these. So you see division, like factoring division problem, you know you have to
Yeah.
do that for restrictions,
Yeah.
and then you're going to factor and cancel.
Yeah.
So I think you already know that. You wouldn't have to write that down, factor and cancel.
Yeah.
Okay, good. All right. So
Okay,
let's
so then
factor
for
these
this
two
one-
bottoms.
Okay, so
So I think the key in factoring, whether you struggle or not, is writing down the factors.
yeah, that's
One
what I
in-
usually do, but sometimes
Good.
I can just see it.
Yeah, that's perfect too.
Okay, so negative.
And then double check every single time on your calculator too. So do you know that if C is negative, you subtract the factors? So if you think like ax
Oh,
squared
yeah.
plus bx plus c, c
Yeah.
negative, subtract factors. So negative 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8.
Okay. Okay, so then.
What's 8 minus 5?
Oh, it's negative.
That's
Negative
your
8
little
plus
double
5.
check, right? You just say it in your head. You can even say it out loud.
Yeah.
And who cares if people think you're crazy?
Yeah.
Right? You say it out loud because a lot of times if you can hear yourself say it,
Yeah.
you're like, wait a minute, that doesn't work. Or if you
Yeah.
can see it without saying it,
Yeah.
even better, right? But all
Okay.
right, so now
So now you change it. So
what
then-
I would do is this. Let me just
So you
make
change
all
it to
this.
multiplication and then cancel it out.
So no, because what are we doing?
Adding.
So I would write like add going up vertically, like ADD. Just so you see it, right? Because kids mess that up all the time and it makes you crazy when you miss a problem you shouldn't miss.
Yeah.
So when we add, we need a common denominator. So I'm going to write these right below, like x minus 8, x
Write
plus
it.
2. You can write it
Oh,
again.
I
either
remember
way.
now. I remember now.
Okay.
So
X minus 8,
x plus 2, and then you make your least common denominator.
Yep.
So then,
So your LCD has everything in the denominator,
Yeah.
no repeats.
so x minus 8, x plus 5. So then the LDC is going to be x minus 8, x plus 2, x plus 5, right?
Good. So
So then
like-
you multiply.
everything in the
what?
denominator, no repeats. I don't know if you
Yeah.
need to write it. I'm just going
I'll
to
just
tell you
write it.
things you can write down if you want. You don't have to write them down, right? So everything, no repeats. You could just write that. So right now you can also do your restrictions, right?
Yeah, because
So if we want steps, you could do LCD step 1, restriction step 2. And then I'm just going to give you every opportunity, like everything you could possibly need to study.
yeah.
And then you study whatever you need to, right? But it'll just be good to see it because then you don't have to sit there and stew on it.
So then you have the restrictions are
So x cannot equal.
x can't equal 8, x can't equal -2, and x can't equal -5.
Perfect.
And then
So
then
now,
you multiply by what it doesn't have, right?
yes,
So
multiply
then-
by what's missing.
So then
Perfect.
you multiply 8 over x minus 8, x plus 2 by x plus 5 over x plus 5.
Perfect.
And then plus 9 over x minus 8, x plus 5. And then you multiply that by x plus 2 over x plus 2.
Yep. So then what I'm going to do is I'm just going to write the LCD and combine the numerator, write the whole numerator in the top, right? Because I'm adding, I can do that.
Well, can't you also, oh no, this is not that. Okay.
8x plus 40, right? For this part. I'm basically distributing into that parenthesis. And then 9x plus 18. So plus 9x plus 18. And the bottom is all your LCD.
So then it's just. And then that is,
Then you just combine like terms, right? Yep, good. Use those fingers, love it.
so 17x
Plus 58
is 58
over that whole denominator.
Yeah, I'll just write that here because I don't know. Okay.
I would definitely do that so you don't have to keep writing it over and over again because it'll make you crazy. It's annoying, right? You're like, God, why didn't I just write it there? Because now I got to move it. Will she take points off if you don't put it in the right spot?
I don't know. I just want her to make sure she sees it.
So some people will do that, teachers. I think, I don't know if Cheryl still does that because you're doing stats next year, right?
Yeah.
Like, she used to. I don't know if she still does. I hope to God she doesn't. If you didn't box your answer, she would take points off.
Really?
And I'm like, you can't, like, I think you can't do that.
Yeah.
Like, I could complain to Doan and stop her from doing that, like if I were a student, because your grade on the test is based on what you know, and you putting a box around it is not part of a test grade.
Yeah.
Like, I get pissed about that kind of stuff.
Yeah.
I get mad, like, she doesn't let you use a graphing calculator, because, like, what have we done so far that would not, like, you
Right.
could cheat using the graphing calculator?
Yeah.
Nothing.
Nothing.
Right? And I think that kids can get further along using the graphing calculator, even on the graphs we're going to do later on.
Yeah, because then you can.
It doesn't
it's
matter.
Faster.
You still have to prove everything.
Yeah.
Right? So I don't give a crap if kids have a graphing calculator.
Yeah.
But again, that's me. I shouldn't even say that kind of stuff to you because it would just make you mad. Okay.
Okay, so this.
So
one,
first thing I do is I make a plus and make that a minus. Because you guys do way better when you add things as opposed to subtract things. Because the negative sometimes gets lost if it's in the middle. And if it's up here, it'll never get lost.
Yeah.
Right? So now we factor the bottom. So we're doing negative
So-
12 up top. Negative 4 on the bottom.
So.
Why did she say you
Six.
can't factor?
I don't know. 6
You
minus
must have.
2?
She must have answered one question where you didn't know it.
Yeah.
Like you didn't know it, or like
Yeah.
maybe you didn't hear her.
Maybe.
Is she still using the microphone?
She is.
Oh,
yeah.
thank God.
Okay, wait. 6 minus 2.
So what's 6 minus 2?
Oh, negative 6 plus 2.
So all I want you to do is check every time you write them on the sides, check it in the calculator. And then you'll never make that mistake, right?
Yeah.
So I just cross out the fraction or the bottom right here and I just write that x minus 6, x plus 2 below. So I don't have to keep writing the damn thing like 100 million times. So what's missing from the first one?
X plus 2.
Good. And do you like to foil or use a box to foil?
I'm fine with foiling.
Okay, so foil that up. You can check your answer once I do it over here.
Okay, so then.
It's funny, people get all like they just love foiling or they love one method or another.
Yeah.
I personally don't care. I'm like, do the one that works the best for you because that makes
Yeah.
sense.
Okay. Is it 2x squared plus 5x plus 2?
Good. And then don't forget that.
Oh, minus 8.
So just write minus 8 after. And then just write it on the answer because you're going to combine like terms right there, right? x squared plus 5x.
2 minus 8 is negative 6.
Good.
X plus. And then okay.
So you got everything perfect, sweet. So this is a good one for, especially this one, to write like a lot of little hints and stuff for number 6. Number 5 is a good warm up to the whole concept.
Yeah.
So,
So the vertical
what do you know?
asymptote, do you do x plus 2 equals 0?
X minus 2 equals
Or
0.
sorry,
but
x
yeah.
minus 2 equals 0, and then it's 2
And then,
so then
make
you
your
put
dotted line.
at x equals 2, which is vertical at 2.
Yes, perfect. Is it motivating you to hear that she thought she couldn't factor? Just out
A
of
little
curiosity?
bit.
Good. Because it's like, I kind of want to make you mad about that. So you're
So
like,
I'll do
kiss
good at
my
it."
butt. I can do this.
Yeah. Okay, and then the horizontal. Oh, you said the numerator equals 0, right?
So if we just have this whole fraction, what does this do to it?
It puts it up 3.
Up 3 horizontally. Right? So the n right here is up 3, so y equals 3.
Oh.
So you remember this formula, right? Oh God, that is super tiny. So this formula, that's y equals a x minus h plus k.
Y equals. Okay, yeah.
And then every single time I write this, because it's always the opposite sign there, and it's always same sign over here. So we know that that plus 3 is y equals 3, because it's the same sign.
So then that's at the x. It's there.
This is going to be your best test score,
I hope so.
despite the partner test, because that's a whole different thing, right? Partner
Yeah.
test, especially because you and Alexis did it, right? And as I remember, like, Alexis had one part of it really well and you had a different part of it really
Yeah.
well. So putting you two together was like perfect, right?
Yeah.
Because then you could dominate. That's beautiful. Okay.
What does it
So
mean when it says x and y?
don't worry about that yet. Let's
Okay.
do x-intercept, y-intercept next.
Okay, so
So
for
what
the
is-
x-intercept,
What do we do?
you do
So think about it. If I have this dot on the x-axis, what's y? X equals -3. What's y equal?
0.
So you plug in 0 for y. So
Oh.
I would write that plug in 0 for y so you remember. And then don't write it yet. You tell me if you need to write it. So if I plug in 0 for y, what's my first step?
Subtracting 3.
So I just write -3 equals that fraction,
Oh.
right? But again, don't write that if it's going to mess you
Well,
up.
I'm just going to write both on here just so
Okay, that's great. You just be careful about all that kind of stuff, right? Because I don't want to mess you up.
That's fine. And then you multiply both sides by x minus 2.
Yep. Do you ever think about it like this? All I'm doing is cross multiplying when I do that. Because some kids like that concept of cross multiply better than multiply by the denominator. It doesn't matter, both work. But
So then, 3x plus 6 is -5, and minus 6 minus 6. So -3x isn't that -11?
yep,
-5 minus 6. And then divide by -3, so x equals 11 thirds.
perfect. So 11 divided by 3 is, I think, 2.7, but let me double check. 7 divided by, oops, I did too many divides. Clear. 3.7.
Okay. And the y-intercept.
And then
you
make
put
your dot.
X.
3.7 on the X. Just like take care of it right away so it doesn't mess with you.
3.7.
And she'll let you use the colors on the test too, right?
Yeah.
Good. Because that's helpful, I think.
All
All right, so y-intercept, what do you plug in 0 for?
X. So
Perfect.
then you have y equals -5 over 0 minus 2 plus 3. So then -5 over -2 plus 3.
So 2.5 is 5 divided by 2.
So negative. Oh.
Negatives cancel, right?
Yeah. So 2.5.
So 5.5. Okay,
then
so make your dot at 5.5.
Okay.
So the whole XY thing, she wants you to have 2 dots up here and 2 dots over here.
Okay.
Okay, so how do you know what X value to pick? I just pick an X value close to this X value right here. So I'm not going to pick -1, I'm going to pick +1 because it's the easiest number to plug in,
Okay.
right? So I'm just getting close to this dot. I can look at this vertical asymptote and just pick the easiest number on either side of it, right? So I can plug in 3 and I can plug in 1. Wait, this is 3. Yeah, we're good. Okay,
Okay.
so I'm going to plug in 1 first.
So then y equals -5 over 1 minus 2 plus 3. So then -5 over -1. Yeah. So then 5 plus 3. So it's 8.
Yep, perfect.
So then that's 8.
So
then
you plugged
at
in 1 and you got 8.
It's 8.
And then you can just draw the rest of that graph, right? So the asymptotes force it to go like that.
Oh, oops. Like it goes like down.
Yeah, just the asymptotes like constrain it into, and the graph always goes right next to them.
Yeah.
Okay?
And then this one.
So then we're going to plug in what?
3.
Yep.
So then y equals -5 over 3 minus 2 plus 3. -5 over 1 plus 3. -5 plus 3. So -2.
Perfect.
And so then it's -2.
So then your graph comes from the bottom. It's going to go up like that. Perfect.
Good.
Okay. So domain is everything except this vertical asymptote, right? Because it's every x value except 2. So x such that x is not equal to 2.
So can you use the vertical asymptote for that?
Yes. So VA for domain, HA for range.
I'm just color coding it.
Smart.
Okay, so then for range, y can't equal 3.
Perfect.
Okay, cool. And then for transformations, it's vertically compressed by 5 or vertically stretched by
Stretched by 5.
Well, because
Oh,
it's
so
-5.
it's negative, so all that does is reflect it over the x-axis.
Oh,
So reflect x-axis. I realized I missed transformations, and when I did this with Alexis yesterday, we missed this.
Oh.
But I'm going to share this video with her so she'll see
okay.
it. So reflect x-axis, vertical stretch by 5. And then what does that -2 in the bottom do?
it moves it right 2,
Right 2,
and then up
and then
3.
up 3. Perfect. You're a freaking rock star. Like, that's good, right? Because a lot of
Yeah.
people can't just rattle that off like that,
Yeah.
so that's good. All right.
Okay, so now
So number 6, first thing you do, factor
the top and
completely,
the bottom.
right?
So then the bottom goes to x plus 2x minus 2.
Yeah, you can factor it all.
And then I'll write down for this one. So then it's negative 6 and then negative 1. So then it's
What's 6
2
times?
minus 3.
Yes.
So then it's x plus 2, x minus 3, and then the x plus 2's cancel out.
Perfect. And what does that make when they cancel?
A whole.
Good. So what's your whole then?
X equals negative 2. Oh, wait, no, sorry.
No, you're right.
Put in.
You said whatever you cancel equal to 0.
Oh, okay.
So you could write x plus 2 equals 0. So you remember you said it equal to 0 like that, when x equals negative 2. Then how do you figure out the y value of the whole?
Then you put it in for x.
You plug into what's left.
Yeah, so then
Okay.
you put negative 2 minus 3 over negative 2 minus 2.
Perfect.
And then negative 2 minus 3 is negative 5 over negative 4.
Which is 1.25.
4. So negative 2, 1.
And then I would write that like an ordered pair because I guaranteed she wants to see it as an ordered
Yeah.
pair. And then you can make that whole at negative 2,
Negative
1.25, and just make,
1.
I make it like big and fat like that. Like, yeah.
Wait, oh shoot, I did it wrong.
So negative 2 on
Wait,
x.
no, I did it right.
Negative 2 on x.
Oh, yeah, I did it right. Negative 2.
I don't like my whole anyways.
Okay, there's that.
Negative 2, 2, 5. Okay. So then VA.
So then the vertical asymptote is 2.
Yep. So horizontal. And if you don't remember how it works, I'll tell you because,
Is it the degree?
yes. So when the
So-
degree's the same top and bottom, you set the coefficients equal.
And then there's 0.
So
Wait,
1
but
over
isn't
1?
the degree, like, wouldn't it be x to the third?
No, because it's the highest exponent is degree.
Oh, okay.
You can't add the x's,
Okay.
right? If you were multiplying, it would be x to the third, but because we're subtracting, that's why it's not.
Okay.
So highest exponent, so y equals 1. And then I would put those in. So y equals 1.
So the vertical asymptote is at positive 1, 2. And then y is 1. There. Okay.
All right.
Okay, now the x-intercept, you just do
What do you plug in for 0? Good. So 0 equals,
x minus 3 over x minus 2. Then you multiply by x minus 2. That cancels out. And then you have... Wait.
it's messing with your head. Don't let it. What's 0 times that?
Not 0.
So write 0 equals, what's
X
0
plus-
equal?
Oh, x minus 3. And then you add 3.
See? Don't let that freak you out. I know you're like, wait a minute, what the hell's going on?
3. So it's 3.
0 equals x minus 3. So you're, when you plug in 0 for y, you get 3 for x. So 3 comma 0. Write it like an ordered pair so it doesn't mess with you.
And then
So count from the y-axis. It's easy to mess that up, right? So come from there. So
the y-intercept you put in 0, or no, you put in 0 for x.
good.
So
So
you do
y equals
0 minus 3, and then 0 minus 2. So then you have negative 3 over negative 2.
Which is 1.5.
1.5?
Yep.
Okay.
So you get 0 comma 1.5. Like this, the hardest thing about this problem is just like keeping it together, right? Because
Yeah.
there's so many little things to remember. It's like just gets a little mind blowing eventually here.
Yeah.
So 1.5, right? So let's do domain and range is easy to do,
Okay.
right? Because it's everything. You look for VA for domain, HA for range.
So it can't equal 2. And it also can't equal -2, right?
So because there's a hole, that's true. 2 and -2.
Yeah, because of the hole.
Yep.
And then
And then the range,
can't equal 1 or 1.25.
1.25. Telling you. All I got to do is tell a kid the teacher doesn't believe in them, and they just fully dominate. So you keep that vibe going during the test too. You're like, I'm proving you wrong.
Yeah.
I'm proving you wrong.
Yeah.
You can make, like, I can't tell you, Ruby, the evil things I thought about my calculus professor. And I loved the dude. Like, we were buds. Like, I went to every single office hour except the very first one. But when I was taking a test, I was looking at him. I can't even tell you the horrible things I would think about him because he was tough, man.
Yeah.
He just would mess with you. And I'm like, dude, like, come on. You're killing me. Okay, so we got to do this X, Y thing.
Yeah.
Last thing. And then she didn't make you do transformations on this, strangely,
Yeah.
but that's okay. All right, so we're going to look at the vertical asymptote and pick on either side. So we're not going to pick one of the points we already have, obviously.
1.
So I would pick 1. That's a good one. So let's plug in 1, see what happens.
So then,
So, and you plug into what's left again, right?
yeah. So 1 minus 3
3,
over
perfect.
1 minus 2. So then 1 minus 3 is -2. 1 minus 2 is -1. So then you have 2.
So 1 comma 2, make your dot.
At positive 1, 2. Okay.
And then on the other side,
you could do negative.
no, we're already good on that side, right? So we want on this side.
Yeah, sorry, positive 1, 2, 3, 4. You could do
4 is perfect. That's what I pick.
So then you can do 4 minus 3, 4 minus 2. So then 1 over 2. So 1/2.
0.5.
So then
So-
at 4 it's 1. So an x is 1, 2, 1, 2, 3, 4. It's at 0.5. Okay.
And you draw your graph.
So then it goes
It's
like,
like a hard right turn.
yeah, that.
And then when you draw it, you just skip the hole.
Yeah.
So this is what I'm talking about. Like, I let these kids use a calculator. Who the hell cares? Because you still have to prove everything.
Yeah.
And I think, like, my whole thing on letting them use a calculator too is if you make a mistake with, like, the vertical asymptote and you can see it on the calculator, you can look at your work and fix it.
Yeah.
And do you learn more if you do that?
Yeah.
Yes. Isn't that why we're all here? To learn? So I'm
Apparently
like,
not.
oh, look at how smart that is.
Yeah.
And but teachers are like, I'm literally the only one who let kids use graphing calculator on everything.
That's so weird.
And I just think it's a powerful learning experience. Like,
Yeah.
it makes more sense to do it that way.
Yeah.
Okay, we're almost there.
Okay,
So I look at this one.
factor everything.
So I'm thinking that if I multiply these two, I'm probably going to get this. So if we look at this, what's y times 2y? Actually, I'll do it on here so you can
2y
see it on the
squared,
video. Yeah, so if we do y times 2y, we get 2y squared. Good.
Yeah.
If I do outside, I get positive 1y. If I do inside, I get negative 10y. So what's 1 minus 10?
Negative
Negative 9.
9. Yeah.
Bam. And then if I do the last, I do negative 5 times 1, I get negative 5. So what's my LCD? Well, I already know it.
Can I
So-
actually factor it out though? Because I
You
can't
can.
always see it. Well, can't you factor
You can
this?
you can just foil this to
Oh,
see if
no,
you
you
get
can't.
that. That's how I would do it.
Oh, okay.
I wouldn't factor it because it's harder. I would just foil it to
Wait.
see if you get that. Because they're going to design this problem so you get that every single time. They're not going to make it any different. So I
Okay.
would just FOIL those and see if you get that. And then if you don't, you have to factor.
Okay.
I'd rather have you go that way because it's easier,
Mm-hmm.
right? Because if you factor that and you screw it up,
Yeah.
then you're going to like blow up that problem.
Yeah.
Because I guarantee you, you're going to be able to multiply those two and get that one on the test as
Okay.
well. So yeah, FOIL it out.
So then 2y squared minus minus 5. So yeah, they're the same. Oh, so then your LCD is going to be y minus 5, 2, and then 2y plus 1?
Exactly.
Oh, okay.
Exactly. I'm just going to show the box on the video.
And then that would mean that your restrictions are y can't equal 5, and then y can't equal
You can do that in your head.
negative
Just
1/2.
saying yes, and do it. Show it out on the
Yeah.
test. But
Oh, and then this one is where you multiply everything by everything, right?
so you multiply all of the numerators. I'm going to go like this and copy this. Paste.
Because like when you do like 4 over y minus 5 times y minus 5 2y plus 1,
So like
even if
this.
it already has that and you cancel
You
it
just
out.
multiply it by the whole LCD, yeah. So I show like this, y minus 5, 2y plus 1. If this is a like stop and pay attention moment, stop and pay attention. If you get it well enough, then just,
I think I get it.
yeah, I think you do too from what you said. 2, oops, y minus 5, and 2y plus 1.
Over 1.
The last kid I tutored, he missed this day.
Oh,
So he
gosh.
was just like, oh God, what's going on?
Yeah, that sucks. So then y minus 1 over okay, over 2y plus 1. This is great. It's like wait. So then if you're not factoring this, when you
Look at that.
you just cancel it out
Yes.
at the bottom.
That's the beauty of it, right? Because you get rid of those denominators and you can just solve for y.
Okay. Yeah. Wait, so do you you don't multiply that part by anything then, right?
This last
Like you-
part,
like you
so
would multiply
because I'm
44 by
multiplying it, yeah,
Oh,
no,
you
it's
do?
just 44.
Oh, it's just 44.
So I multiply the all of the numerators by the LCD,
Yeah.
and on the after the equal sign, it just cancels the denominator.
Okay.
So all the denominators cancel.
Mhm.
So then I get 8y plus 4
Yeah.
for the first.
8y plus 4 plus.
I'll just do it in my head so we can just get through it
Y
quicker.
squared
Y squared
plus
minus y squared minus 6y plus 5. Just foiling
Minus
it in my
6y?
head. So look right here. So we're multiplying the y minus 1 times the y minus 5, right? And if I FOIL this, I get y squared.
Yep.
Outside's negative 5, inside's negative 1. So y squared minus 6y. And if I multiply these, I get positive 5. That messed with your head. You can just FOIL. You could write it off to the side and just FOIL
Yeah,
it
that's what
like
I-
that. And
Just
it's
so I
a
wouldn't
really,
mess up.
it's a really good strategy. Like when I took calculus, I did that all the time
Yeah.
because the whole problem would overwhelm me. But if I could take a piece, solve it to the side, and plug it back in,
Yeah.
then I wouldn't freak out as much.
And then negative 5y. And then plus 5.
And then you just combine like terms.
And then minus y. So then,
Y squared plus 2y plus 9 equals 44.
and then y squared minus, oh gosh. So negative 5 minus 1 is negative 6 plus 8 is 2. So it's plus 2y. Plus 9. Equals 44.
Yep.
And then do you have to factor that?
Yep. Because
then-
you subtract 44 from both sides. You could erase that just so it doesn't get in your way.
So then do you do
Minus 44, and you get negative 35 when you do that.
So then y squared plus 2y
What's that factor to?
minus 35.
You're going to get it. Have faith. Unlike some people. I'm putting pressure on
7
you
and
too by
5.
saying yes,
So
good.
7 minus 5.
It's good. Respond to the pressure. Is 7 minus 5 positive 2?
Yeah.
Yes, good.
Yes.
I just want you to check that every time.
Yeah.
Okay, so you did it right.
So then it's
So then you
x
write
plus
2 parentheses, right? Y plus 7 and y minus 5 equals 0.
equals 0,
And then you set both of those equal to 0. So y plus 7 equals 0. Write it down here. You got plenty of space. Y plus 7 equals 0. And then y minus 5 equals 0.
so then y equals negative 7 and
Perfect.
y equals 5.
Is y allowed
And
to
then-
equal 5?
No, so that's
So
extraneous.
just cross that out. Yay, look at you
Yay.
go.
So then y equals negative 7. And then I'll just put like,
And then you say, hell yeah.
oh yeah.
Because that's a pain in the butt, right?
Yeah.
And if you think about you on the test, right?
Yeah.
You do this problem and then you do this one right away. Like that's a lot, right? So like I never do a test in order. Like if you feel confident about this one or the graphing one, whichever you feel most confident on, do that first. Maybe do an easy problem first,
Yeah, to
and
get your brain
then
worked up.
like don't do them back to back. That's all I'm saying. Like
Yeah.
space them out because you'll get like mentally fatigued,
Yeah.
and you're more likely to make a mistake when you're mentally fatigued,
Yeah.
right? And if you do those back, because that was a lot of crap, right? And this one's even more. It's like a strange amount of pain in the ass. This
Yeah.
one, because you got to test everything.
Yeah.
Have you seen the key? Let me show you the amount of work on that one because it's like, oh my god. So that last one,
Oh my god.
so see it goes all the way down there too. We're gonna skip a bunch of this work
Okay.
because there's shortcuts that she writes everything out, and I don't think you should. You don't need to, basically. Did I start that? Okay, so now we're gonna, first thing you do LCD. So what is every part of the denominator? We have a
It's
2
and then x minus 4,
and
x plus 5. And then the restrictions would be x can't equal 4, x can't equal negative 5.
so I'm gonna multiply every numerator. First thing I'm gonna do, I take it back, is switch this minus to a plus
And then that's
and make the 1 a
negative.
minus.
Yeah.
And then I'm gonna multiply every numerator by the LCD.
So then 3 over 2 times 2x minus 4 x plus 5 over 1 plus negative 1 over x minus 4 times 2x minus 2x 4 x plus 5 over 1 equals x over
Then we're gonna cancel.
x minus 4, yeah. X plus 5 over 1. So then cancel the 2 out from that. And then the x minus 4 from that.
And we're just gonna do this quick right here just to make it easy, right? So I get, let me just do it. So we get 3x squared plus 3x
3
minus 60.
x squared plus what?
3x minus 60. So
Plus
this
3x
is what I
minus
just did in my head is I foiled that and I multiplied by 3 at the same
Oh,
time.
okay.
Okay, so you would just show the steps for
Yeah.
that, right? And it's fine. And then we're going to do
plus-
negative 2 times x plus 5
So negative 2x plus 10.
minus
Or
10.
minus 10. Negative. So wait, sorry. What did I just say? Negative.
Negative 2x
2x.
minus 10. And then we're going to think about this right here as 2x, right? So just 2x times x minus 4. So it's going to be
X.
greater than
Oh, great. Yeah, I forgot about that one.
2x squared.
Well, wouldn't it be 2x cubed?
It's just 2x times x.
Well, because it's 2x times. Oh, yeah.
Okay.
2x squared.
It's okay.
And
And then 2x times negative 4.
So it's negative 8x.
Negative 8x. Now we get everything on the left side.
Yeah.
So we're going to subtract 2x squared, add 8x, same time, negative 2x squared. You could combine 3x and negative 2x to get 1, right?
So then you get x
And
squared
then I'm adding 8x.
plus 9x, right?
Yep. So we get x squared plus
Minus
9x minus 70.
It's greater than 0.
Yep.
And then you factor it.
So negative 70 on top. I'll be your human calculator on this one.
Thanks.
It's 14 and 5.
So then you have x plus 14, x plus 5 is greater than 0.
I can't believe she said you can factor. My God.
Well, my mom told me that, and I was like, what? I can factor? And she was like, well, maybe I said it wrong or something. I was like, I don't know what.
No, totally. Because we were texting back and forth about it. I was like, I'm worried. Because
Yeah.
if you truly couldn't factor, this test would be a nightmare, right?
Yeah.
Like you'd be cooked.
Yeah.
You get like a 28% on the test. And I was
Yeah.
like, she told me that and I didn't really believe her, but I had to make sure, right? Because like
Yeah.
I feel responsible,
I was
you
so
know?
confused. I was
I'm like, what the hell?
I probably got like one thing wrong.
She asked you one question, you got it wrong, and then she's like, she has no idea.
So x is equal to negative 14, and x is equal to negative 5, but x can't equal negative 5.
Greater.
Oh yeah. So x is greater than negative 14, x is greater than negative 5, but x can't. Oh, you just do both.
Yep. So 5's over here, and she didn't like count out on the number line. She just kind of wrote them where they would go because there are
Okay.
not enough spaces on the number line.
Okay.
Now we need to talk about restrictions, right? So x cannot equal what?
Negative 5,
And
4.
so then we're going to throw in negative 5 over here as well, and we're going to throw 4 in here. So the rest of this nasty little work that was done is testing. So if we look at this thing, you have to test this value, you have to test the middle, you have to test a value in here, you have to test a value right in there, and a value in there. So that's what the A, B, C, D, right? So
Yeah.
A, C, E, B, D, she did it in a weird order, but that's basically what you're doing.
Okay.
So you would plug in like, so you plug it into the original, right?
Right.
So 3/2 is 1.5, it makes it go quicker. So, and then I would label it, right? So we have a slash here, not at 0, at 4, 5. So I would call this A, in between B, in between this one C, this is D, and this is E. And then you label them so she knows exactly what the heck you're doing, right? So A equals, you have 1.5 minus 1 over, we're going to plug in like negative 15. So x equals negative 15. You could write that first, actually, that would be smart. So negative 15 minus 4. It's just, this is the definition of tedious.
Wait.
I'm going to show
Isn't
you,
it
hold
negative
on.
15? Wait, where did you get negative? Oh. But isn't it negative 15? Oh, minus. Yeah.
Because I'm
never
just
mind.
testing over here, right? To see if it works on that side. negative 15 over negative 15 plus 5. So if I'm doing this in the calculator, I'm going to go like this. I'm going to go per negative 1 divided by parenthesis negative 15 minus 4. And then you get 0.05. So we have 1.5 minus 0.05. And then I'm going to do that same thing with this negative 15 plus 5. Do you know about the insert? Because it's handy.
Oh.
So you can do negative 15 and I can just change this to plus 5. And then I don't have to type everything in time after time.
Yeah.
So equals 1.5. So if I do 1.5 minus 0.05, it's going to be smaller, not bigger than 1.5.
So it doesn't work.
So this one fails. So you got to do that for every single one, which is just a total pain in the butt.
Okay.
And this is easy to mess up.
Yeah.
When you do this, I would for sure, because your mom's probably here, check every single thing.
Okay.
And
And then what do I write the answer?
oh, this one is plus right here because it's negative over negative.
Oh yeah. Okay.
So it's plus. So this one works. It's true. See, I made a mistake. But that's like, so once you finish a whole test, if you have time, all you do is go back and look for those negative mistakes.
Yeah.
Like just check a problem for negatives. Don't do the whole thing. Just like check your calculations and make sure you didn't mess up a negative.
Okay.
You should be good.
Okay.
You're a rock star. That was
Thanks.
awesome.